Yeah, wait a minute. I just introduce you. You can't jump into the presentation. You need to wait for me to introduce you, okay? So
Okay.
here you all, gentlemen and ladies, we have the last presentation of the 2 days seminar, 2-day virtual forum, 21st presentation, being led by our Vice President, Infrastructure and Smart Cities from ARC Advisory Group USA. And he's speaking live from USA. So we are very thankful for him to speak live from USA. He's going to speak on the smart city planning using the IEEE Smart City Planning and Technology Guide. The stage is yours for you, Jim, and please take over.
All right. Ramon, thank you very much. Let's see. Are you seeing my screen?
Yes, Jim, we can see your screen.
Okay, would you like to seeing the slide or the presenter view?
Yeah, would you like to change the presenter view?
No, are you seeing just one slide?
Yeah, no, we can see the both slides.
There we go.
Yeah, all right, thank you.
All right, well, hey, thanks everyone. That is true. I am speaking to you from Miami, Florida, over here in North America. Thank you very much for inviting me. Today, we're going to take a quick look at a structured planning process for public infrastructure projects using the IEEE P2784 Smart City Planning and Technology Guide. So I'm your moderator, and I'm actually the Vice President of Infrastructure and Smart Cities for ARC Advisory Group, and I have chaired a number of different initiatives in the standards development world in the past. Currently, I do chair this standards effort, which is about 95% done. Before we actually go into the standard and how to apply it, just a foundational note that there really are 3 pillars of digital transformation. The first is a technology refresh. The second is the required business model change that depends on that or is empowered by that technology. And perhaps the third is the most important and sometimes the most challenging, is that it's a cultural change. Your staff, your people, all end users all need to embrace both the use of the technology as well as those new business models. So that's something to think about as we move through our short presentation today. So quickly, we'll look at smart city drivers, barriers and benefits. We'll review the 5 groups of human factors that impact a smart city. We'll look at the 9 vertical applications and 7 technologies of a smart city. We'll look at some other standards in the area, and then we'll look at the actual planning guide and how to apply it. So what are major smart city drivers? Growing urbanization. Many people are moving to cities, even in these days of COVID. Growing stress on the infrastructure and on the people. Inadequate infrastructure, not designed to support that growing amount of people. And growing economic competition. No longer is it adjoining cities, but cities are competing against other cities across the world. Growing environmental challenges. People are expecting cleaner air, cleaner water. Growing expectations are another one. Now that everyone has, most of us have smartphones, we're becoming acclimated to almost immediate responses. And then, of course, rapidly improving technology capabilities in everything we do, from our vehicles to our computers to just about everything, to light bulbs. Some barriers are that all of this evolution does require quite a bit of information and communications technology domain expertise. And training of those folks really is something that we need to focus on moving forward. I know that across the breadth of ARC's studies and work, we often talk about siloed piecemeal implementations. The communication backbones and this IoT infrastructure all really should reduce, and its effect is greatly enhanced if silos are removed, so that the water meters can communicate on the same backbone as the traffic signals. And then, of course, lack of capital and financing. However, there is some movement in that area with some creative finance models that are basically a subscription basis. And perhaps the one that is least well known, and probably one of the biggest impediments is lack of citizen engagement. How do you know what you should be doing if you don't really know the user needs of all your stakeholders? So benefits, of course, they're fairly obvious. Enhanced livability, which is lower energy costs, better schools, faster emergency responses. Enhanced workability. Well, in one word, jobs. And jobs are driven today by broadband connectivity, by lower cost energy, by educational opportunities, lower cost space to live in and to work in, and efficient, cost-effective modes of transportation. As we know, in many developing countries, cost-effective and efficient transportation is a critical factor. Now, we can't leave sustainability out of the equation, and there are three pillars of sustainability. The first is preserving and enhancing the natural environment. The second is preserving and enhancing the human quality of life, from those jobs down to a safer crosswalk in an intersection. And the third pillar is doing the first and second in an economically reasonable way. Think a quick payback here of 2, 3, 4 years, or even shorter for some applications. So then now that we've established that foundation, let's look at the 5 groups of human factors that impact a smart city. So they are social, technological, economic, environmental, and political. And we'll look at each one of those in a small amount of depth. Social factors include, here's 20 that we've listed in the IEEE standard. Everything from population growth to the aging of society, changing household patterns. In many places of the world, households are going to 2 ends of a continuum, single-person households as well as much larger households. The growth of the global middle class, certainly today, infectious disease responses is important. But all of these truly are important and should be considered as you plan what is your smart city. Similarly, those of us in the technology world know that there is a range of technology factors from just simple IoT to intelligent transportation systems, the issues of cybersecurity, 3D printing and additive manufacturing, all are important. And we have, of course, economic factors. The aging of infrastructure, maintaining older infrastructure, the skills shortage that we touched on earlier. How do you promote small business? And what about supply chain vulnerability, for example? City identity. Many cities, particularly for tourism, have branded themselves as almost a retail entity. All of these are important. Environmental factors, certainly clean air, water, general pollution is all important. But some of these you might not think about as much. In terms of perhaps promotion of non-motorized transportation for better air quality, heat stress and heat islands in very developed areas. How do you retrofit a building? Some of those kinds of things, all are important. And lastly, political factors. How does your government define how much public space is available to you? What about building standards, and how do they impact the cost of places that you might live or work? Policing, the form of your urban governance. What kind of government do you have? And then, of course, public-private partnerships and the related privatization are very important today. So that's a quick view of those 5 groups of human factors that you really should consider as you start planning your smart city. So let's quickly take a look at 9 applications and 7 technologies that most public agencies support. Now, we borrowed this graphic from the Smart Cities Council, which arguably is one of the larger smart city trade organizations out there. And you'll see across the top in the red box are 9 applications. Buildings is number 1, energy, telecom, transportation, water and wastewater, health and human services, public safety, payments and finance, and of course, garbage or waste management. So your public agency or city or county or nation might not do all of these, but in all likelihood, you'll do most of these. So these are the applications that you might want to think about when you start evaluating those human factors and what you might need in the future for all of these applications. And then, of course, in the column on the left are 7 technologies that impact all of these applications. End device instrumentation and control, connectivity and broadband connectivity. Interoperability is not thought about often enough. True 7-layer OSI interoperability. Security, privacy, and cybersecurity, personal privacy. And then, of course, how you manage your data, where you manage it, how do you source and manage your computing resources, and what type of analytics do you apply to actually derive business intelligence from all that data. So this standard is an umbrella planning standard, and it by no means is it the be-all end-all for every smart city application. There's many standards that impact public infrastructure and all those different vertical applications. There's lighting applications, there's ITS applications, there's a range. So this is really meant to be what you do on day one as a public works manager, as a city elected official, as a perhaps city manager, county manager. So what's really in this planning standard? Well, it has 3 major sections: how to create a plan for your smart city, an overview of those 9 vertical applications and 7 technologies that impact them, and where to go to learn more. So where to go to learn more really is that reference, is a large reference book of every related standard that you might look for, at least the ones we could source in our standards community, that you can go to learn more for a particular application, say for lighting a roundabout or traffic signal timing issues. But let's focus on section 1, because this really is the largest obstacle to building effective smart cities. What do you do on day 1? What do your customers want? What do your end users want? What do your taxpayers want? So the approach that the IEEE has taken really is the systems engineering process. Some of you computer science folks, you might recognize it as the waterfall V model. And in the first step, you develop user needs. And you start this by defining your stakeholder communities comprehensively. So you might define your bicycle community, taxpayers, elected officials, maintenance operations people, and many communities. Then from each, you would extract a narrative. What should we fix? What could have the most dramatic effect if we were to upgrade our infrastructure? And then in the third step, we would examine those user needs to determine which have consensus. So that once you have consensus-based user needs, you can develop functional requirements, measurable functional requirements that can become the foundation for a project specification, an RFP, an RFI, or something measurable. And then to keep yourself basically on track so that you do satisfy all of those consensus-based needs, but not allow yourself to inadvertently introduce other requirements, you created test plans, incremental test plans from sub-device to device to the entire project. So these are the 3 classical steps of SEP that are outlined in the IEEE planning guide. So this is just a list of your stakeholder communities. I won't read all of them, but certainly ones I didn't mention are utilities, the business community, maybe pedestrians, maybe some of your larger agencies, either adjoining agencies, adjoining cities and states and counties, can also be considered. So this is that same SCP model graphically. You work from left to right, down this yellow V, down one side and back up the other. And you begin with concept exploration. You move to concept of operations, which is where you define and document those consensus-based needs. And then you move into requirements and subsystem requirements. So on the left side of the V, it's all user needs based. On the right side, it's the functional requirements side of the V. And you can see that you build those requirements there. Now testing, and it's probably the most critical part of the graphic, is that you notice in my first red arrow, or my small red arrow there, it's an arrow that shows unit testing is dependent upon the user needs of the component. Subsystem testing and testing the functional requirements of a subsystem is then dependent on the subsystem user needs, and so on, up through the verification and validation plan. So key concepts of using the systems engineering process is that it includes and supports the entire life cycle of the system. It focuses very strongly on stakeholder involvement of all your stakeholder communities. And it forces you, it structures an approach that forces you to understand the exact problem to be addressed. It addresses project risks as early as possible so that, well, for example, you don't build a bridge that doesn't include a bike lane and find out you needed a bike lane later. And it clearly documents the process and the output of each step. And of course, it's scalable. You can use it for small projects up to very large projects. Now, benefits and costs. It certainly improves the quality of the products and the processes and the things you create. It reduces the risk of schedule and cost overruns because mistakes and errors and omissions tend to be recognized earlier in the project when they're less costly and less impactful. It does increase the likelihood that user needs will be met, improves stakeholder participation, and provides better documentation. And it should reduce operational costs. However, nothing in life is free, and there are costs. And of course, the cost is that there is some addition of cost or reapportionment of cost to the front of the project when you do this planning. And then, of course, these testing processes are something you might not have costed out in your original project. So in that first concept exploration phase, you perform your initial feasibility, benefits analysis, and your needs assessment. You look at alternative concepts, and you provide your general justification to move forward. That this is generally a good thing to do. Then you move into your concept of operations, where you ask all those stakeholder communities, individuals in each stakeholder community, the who, what, why, where, when, and how about the system and what you're trying to do. Now remember that your needs are not just for developing and implementing the project, but for operations and maintenance. So you really need to get user needs out of those communities too. You know, who's maintaining it, who's repairing it. Eventually there's going to be changes and upgrades. So you would simply follow that same SCP process and update the original outputs as needed. And of course, as we stated early on, the systems engineering process covers the entire life cycle. So eventually, your needs won't be fulfilled by the system, or the system may no longer be needed or may not be cost effective to operate. So then you may need to retire your system and begin that full systems engineering process all over again. So I know we're running late on time, so I went very quickly through our slides today, but we quickly touched on what are smart city drivers, barriers, and benefits. We reviewed those 5 groups of human factors that impact a smart city, and actually we looked at about 100 in total. There was 20 in each group. We examined the 9 vertical applications and the 7 technologies that impact public infrastructure. we looked at the standards ecosystem and listed just a small amount of the guidance that's available to build your smart city. And then we looked at systems engineering, which is really the core of what you do on day one to start planning your smart city. So I'd like to thank everybody at the ARC office there in India for inviting me to speak today. And with that, I'll take questions if we have time. And as you're thinking about your questions, I would point everyone to some of the links there on my on this page. Our Smart Cities team is worldwide at ARC. We do have a weekly podcast. We have an active social media presence on Twitter. We have an active blog. We do host some videos on our webinar channel. And then lastly, there's my personal LinkedIn if anyone would like to reach out to me by email or through LinkedIn. So thanks everyone. And do we have any questions?
Thanks, Jim. I didn't find any questions so far in the question panel. So I think it's been great having you joining us and wrapping up some little bit last time. It's been great. Thank you.
Very good.
Thank you for joining us. Yeah,
very good.
Thank you. Yeah.
Thank you, everyone. Have a great evening.
Yeah.
Take care. Bye-bye.
Yeah. Great evening. Yeah.
Thanks, Jim.
Take care.
Come to the last portion of my presentation. And a word of thanks. Before I wind up, I'd like to thank the platinum sponsors, Bentley and Uniper, and also global sponsor Siemens. From your side, I'd like to thank all the speakers who have taken the effort of preparing and speaking in the forum. We also would like to thank all the media sponsors and industry association sponsors who have been supporting us year on year. If not the least, I would like to thank all the delegates who have been kind enough to attend sessions of their interest and supporting us year on year. And there is a feedback form which will come up once your session is closed. So please fill up the feedback form. There are very simple questions. Your feedback is valuable for us to take the next forum. We are still working out the logistics of next forum, whether it will be physical or virtual, depends on the COVID scenario. Though we have planned for a physical forum, but we do not know how this thing should shape. Once again, thanks to all of you.